Good morning, everyone. Thank you for joining this talk about lessons learned when managing MySQL in the cloud. My name is Igor Donchovski, and I'm working as one of the principal consultants at Pythian. It's a company that provides database managed and professional services. I've been working in IT for more than 20 years now. My previous background is also a little bit developer, working with different type of databases like Oracle, MS SQL. Lately, I'm working with MySQL and MongoDB, and my expertise is Bash, Python, automation with hybrid clouds. I'm a husband and a father, and I do talk on conferences from time to time, maybe semi-annually in the spring and in the fall. You can find me on these social networks if you want to connect. So this session is about my personal experience working in the cloud, managing MySQL. It's cloud focused, so it's mostly database as a service, but I will touch base also on managing MySQL maybe on premises or in the cloud on a VM. It's not meant to be a training session, beginner friendly, and if I say that there is no Gen AI content inside, would be probably like saying I don't suffer jet lag, which I do. So there is some Gen AI content like the icons that you see, but it's mostly for visual styling, so it's not the content itself. On the agenda for today, introduction about using cloud configuration, installation on MySQL in the cloud, database as a service, version controlled upgrades, monitoring high availability, scaling, performance tuning, and we will touch base about disaster recovery, security, and hopefully some time for Q&A. Before we dive into using MySQL in the cloud, let's touch base about what are the benefits of adopting the cloud. So going from on-premises or your own data centers in the cloud, obviously there are a lot of benefits. Like in cloud, it's easy to automate, it's easy to scale. It should be cost efficient if you commit using the cloud. If you're not running on demand, it should be cost effective. It's easy to collaborate in the cloud, so different teams can collaborate on many different projects. But more importantly, the cloud is where the innovation is, and it's evolving and evolving every year. A lot of innovation. You, by default, should be compliant with some security policies that your company doesn't need to worry about, but the cloud already has implementation with different security. And it's good for resilience and disaster recovery because cloud is by default designed for disaster recovery. So there are multiple regions, multiple high availability zones, and you are HA and they are resilient. And the cloud actually allows you to define your infrastructure as code. So this is declarative approach. You define your infrastructure as code, and each time you need to deploy your infrastructure, you eliminate the human error by declaring the infrastructure. And there are multiple ways of doing it. One way is to use Terraform or the open source version OpenTofu. There is CloudFormation and Cloud Development Kit. Every cloud has that, and it allows you to declare your infrastructure. It's very easy. One example would be like this is two different versions of AWS and GCP where you can declare and create a virtual machine with just few lines of code. And each time you run this code, it will create the same VM with the same properties. So very easy and very effective. This applies about MySQL in the cloud, about MySQL on self-managed services, about MySQL on a VM. If you are running self-managed MySQL, you probably have a lot of these options to do on yourself, which it's good for flexibility. It allows you to basically choose everything between the operating system version, the operating system type, database version, how you go with high availability, backups. But there is also a burden that you need to scale your team. You need to take care of everything, starting from hardware lifecycle, server maintenance, how you design your HA solution, and so on and so forth. So while there is flexibility, there is also overhead. And if you move from on-premises to the cloud, immediately there are some benefits that the cloud offers. So for example, if you are running on a VM, you don't have to worry about operating system installation and hardware lifecycle. That's done for you. If you go with database as a service, then all of this will be managed for you. So the patching, the database software lifecycle and installation, backups, high availability, scaling, all that is done for you. So your team actually needs to only focus on app optimization, and this is actually database optimization and database performance tuning. If you want to migrate from on-premises to the cloud, the first thing that you need to start thinking of is how to provision your database. And there are a lot of options in the cloud. So even though this is a managed database, you still need to decide and choose. Each cloud has different options, but mostly there will be even free tier, so you can test, see how the cloud works with your application. Then you decide whether this is just a dev or test instance or it's production. And this is where it comes. All this is managed for you. So you have multi-AZ deployment, so high availability by default. Then you run on-demand or reserved instance. If you choose reserved, there will be some cost saving. The storage auto-scales, or you have just to check a button and your storage auto-scales, so you don't need to worry about disk growth and adding new disks. There are parameter groups, especially important for MySQL, because this is basically my.cnf in MySQL. In the cloud, it's called parameter group. Different clouds have different naming, but parameter group is AWS. Google calls these flags. It's eventually the same thing for the global variables. And then you have primary instance or a secondary instance. How you would migrate the data between your on-premises and the cloud. There are multiple options. And there are options that come for free, which you should utilize, because it gives you a lot of benefits, like observability, what's going on with your instance, backups, you don't have to worry about backups. Mostly there will be at least 7 days free tier, or up to 35 days with no extra cost. So you just need to enable this, and it works. High availability, very important if you are running in production. AWS does this in 2 different ways. So here on the left, this is AWS RDS multi-AZ, which is multiple availability zone instance. You get a primary instance, and then there is a Another instance that runs in the background, it copies all the transactions synchronously. So in case the primary instance fails, this takes over, and it's done transparently for your application. However, this instance is not available for any reads. It's just there as a backup. And by choosing this, you realize that there is a second instance, so this doubles the cost for your environment. AWS allows another approach for high availability, which is creating multi-AZ cluster. So instead of one secondary instance that is synchronously copied from the primary, there are two instances in the cluster, and both are available in the reader endpoint of the cluster. So you can query, and you don't lose your rights just by connecting to a single primary instance. In GCP, it works more or less the same, and this is the same in Azure if you're running on the Microsoft cloud. So there is a primary instance, there is a standby instance, and the standby instance is synced synchronously with the primary. So this is not available for your application, but it's just a standby. If you want a read replica, then you need to create a read replica on your own, so your application can query the read replica. And for pricing, as you go with on-demand, the prices are high. If you start committing to the cloud, then the prices start dropping, and there could be up to 60% discount if you commit to using the cloud for at least 3 years, but usually it's between 30 and 50% discount, and different clouds will have these different discounts. Parameter groups, important thing if you are moving to the cloud. This is your my.cnf, and it's very important how you choose the parameter groups. One takeaway from this is that when you create an instance, there will be a default parameter group which you cannot modify. So creating a custom parameter group, assigning it to an instance, then modifying the custom parameter group will allow you to have flexibility. Using the default, you cannot modify anything. So very important to segregate your primary instance, primary cluster with your secondaries, and create different custom parameter groups. Database migration, so from on-premises or MySQL on a VM, migrating to database as a service, there are different options. Every cloud has database migration service. You can use logical backups, or you can use different tools like MySQL Workbench allows you to migrate from Oracle and MS SQL to MySQL. Before going to the cloud, if you don't have a custom parameter group, this will fail because of this setting. Importing store procedures in the cloud, you need a custom parameter group that will have this feature enabled. And the cloud doesn't allow some of the super privileges, so you need to understand that some of the security features are disabled, and if your application is dependent on any of this, you need to work that in advance. One note is when you deploy your instance initially, before loading the data, it might be wise to disable the multi-AZ, because loading the data will be waiting the sync to go on 2 instances, which may take you a little while. And this is also recommended to start creating the instance, so you have at least 7 days backups and performance insights. Minor version upgrades is enabled by default, and this might cause you downtime if there is a new minor version and the automation will kick in, it will start the upgrade and your application might experience downtime. So this shouldn't be enabled by default, so you don't have unexpected downtimes. And also there is an option to protect the instance from deletion, so nobody can actually go and delete the instance by mistake. This is just one line command, how you would migrate from on-premises or from different databases as a service. Let's say your target is AWS, RDS, your source is Cloud SQL. You have a jump host somewhere in between that has connection to Cloud SQL and AWS. And the only thing you need is install MySQL shell, which is a tool from the Oracle MySQL. And you connect to the endpoint that is the source. And you run copy instance and provide these parameters. So what this will do is it will connect to the source, take the copy, transfer to the target, and apply the data set. So it's just a single command. And you just need to check your users and fix if there is any grunt that might not be working between the source and the target, import the users, and you're done. So that is just the primary copy. If you want to continuously replicate the source and the target, which might be useful if you want to do a cutover with as little downtime as possible, usually you would go with change master command or change replication source. This is deprecated in MySQL 8.4. So usually it will go this way, but in the cloud this doesn't work. What does is actually they created separate functions. So there is a call RDS set external master or call RDS set external source GTID purge. So these functions will allow you to make replication between the source and the target. At the end, you are ready for the cutover. You call reset external master. So on this instance, you will reset the external master and point your applications to the new instance. So that is maybe zero downtime depending on how your application buffers your writes. And once you are in the cloud, then it's easy to do this. Just create a read replica and the cloud will take all the burden from you. There is automation behind that will copy the instance, make the replication source, and you have a read replica. This can also be done with infrastructure as code or using the cloud development kit. And if you want, for example, in AWS, it's popular to migrate to Aurora. Migrating to Aurora, it's very easy. You just create Aurora read replica out of your instance, which is RDS. And then, once you have the Aurora cluster, you just promote it and point your application to the Aurora cluster. So again, as little downtime as possible. Major version upgrades. One thing that we learned is it can fail, but you can come prepared. If you do a major version upgrade, then your current version must be up to the latest minor. So, for example, latest is 5.7.41. If you are 5.7.20 and you want to upgrade to 8, it will fail. So you need to be up to the close minor version of the current. Additionally, there are some instance types that don't work with the next major version. You need to do your research. What instance classes work with your next major version and deploy that instance class, or else the major version upgrade will fail. And also, if you have custom parameter groups, you need to take care of the custom parameter before you do the upgrade. This can be done with blue-green deployment in the cloud, where the blue deployment is your current. There is a new green deployment. Everything is done for you in the background. Your blue deployment is copying to the green. Once everything is copied, you just point your application to the green environment and you do a cutover. So also a good feature that you have in the cloud. This can be used for major version upgrades with a failback. So if you are using this, it works only one direction. So the green environment is copied, but if you want to fail back later, there is no automation on that. That needs to be built by you. And it can be done by just using logical replication in the other way. Percona Toolkit, also something you can use in the cloud. These toolkits work with MySQL on-premises, MySQL on a VM, and it will work with MySQL in the cloud. I have a few examples how this will look like, but pretty much the same as it would to any MySQL environment. Very rich performance insights. This comes in AWS with performance insights. If some of your instances doesn't support this, you still have the option to use PMM, also very rich with graphs and dashboards. This is Grafana-based dashboard. Some of the performance issues that typically arise in the cloud and you mostly will work at one point, it's not related to your configuration. So this is the last thing to check. Might be related with with low resources on your instance, but it's mostly related to your workload. So evaluating instances and troubleshooting for performance, this is where you start. Like check your queries, your indexes. Do you have queries that don't utilize indexes? What is the complexity and what is your concurrency? Scaling, horizontal, vertical, you can scale up, you can scale horizontal. This is very easy in the cloud because it's just a few clicks, or you can even declare this in your code. But there are limits. So you can only scale vertically up to some point. After that, you cannot scale anymore. So you need to be thinking about horizontal scaling by sharding. So this is the way to go with horizontal scaling. Shard your instances horizontally. Don't use your data on a single instance. AWS has this feature auto-scaling for reads. Aurora can auto-scale your read capacity by providing some CPU utilization targets and average connections. For security, because you are in the cloud, you have some of the cloud security guarantees that is the responsibility for the cloud, and that makes you compliant by default. But there are additional responsibilities for your team, so you need to be looking at the operating system, your platform, your users, and your client data encryption. So that is still important, and it's for your teams. Prompt engineering, this is something that works with any database, and it will work with the cloud as well. So you can use prompts to generate code for your database and test your application. And still, there are some features that only exist in the cloud. That's where the automation is, and that's where the evolving comes. So this is only available in the MySQL HeatWave environment in the Oracle Cloud. Like they continuously develop new features like this hypergraph optimizer. You have vector store generative AI in the OCI HeatWave, autopilot indexing, and JavaScript store program support. I don't know how many of you are aware that there is a HeatWave product from Oracle, but it's a database as a service. So it's something that you can explore and test. And with that, we're done. Thank you.
Thank you very much. Are there any questions?
Yeah, You mentioned prompt engineering
Yeah.
for testing the database. What kind of testing is that?
So prompt engineering is basically, this example is showing you have some database in your production environment, and what this particular use case will do is you want to test something in your dev environment. So this prompt will just give you 10,000 random records in your test environment with the same table structure. So you don't need to worry about masking the data and maybe security compliance. You just do that on your test dev environment, and it will do the job in 1 minute for you. So it's very easy.
Any more questions?
I assume the minor upgrades with like AWS and that kind of thing, they all fail over to the other node while they're actually doing the upgrade at the same time. Is that how it works?
Sorry, didn't.
The minor upgrades.
The minor upgrades.
The auto minor upgrades. Do they fail over to the secondary?
The minor upgrades, no. So the minor upgrades are applied on the instance itself, but you can choose to promote a new instance if you decide to do so.
Okay, but if you do an auto minor upgrade, does that mean you're going to get a downtime at a random time?
For managed database service, yes. So it needs
Ouch.
to restart. Yeah, that's where you actually need to plan. You need
Okay.
to plan.
Okay, next.
Any more questions?
Oh, sorry.
Okay. Thank you very much.
Thank you.